You got a video? Not photo, right? Okay, good. So, just for the sake of my friends that are watching on the recording, Hess's law says this. If you have steps in a reaction, sometimes you have to add reactions together to get them to produce an overall reaction. There are times that you're going to have to take elementary reactions and turn them around so that the products become the reactants become the products. If you do that, take whatever the delta H was of that reaction and just change its sign. So if you have a reaction that's negative, this delta H is negative, that means it's exothermic. The reverse reaction would be endothermic. So just change the sign on the delta H if you reverse a reaction. And sometimes you're going to have to multiply through numbers. I'm going to show you a couple examples that will make sense to you. This is a very simple example, feeding a truth's misconception. We have two different reactions of carbon gaining oxygen and becoming carbon dioxide. One is where carbon is in the form of graphite. It makes CO2 with oxygen, and there's the delta H for that reaction. Then we have carbon as a diamond reacting with oxygen to make CO2. Did you know diamond could react with oxygen to make CO2? Does it trouble any of you? Girls?
Is there a...
Well, yes?
Is there like an initiator?
No.
You just put them together?
Yes. Two. And remember, I told you it is favorable for nature to give off energy, so it looks like it's very favorable for diamond to become carbon dioxide. Oh, what a terrible shame that would be. However, I will say that you will not do very well if you have a nice diamond like from an earring or from a ring, and you just leave it out in the air. Don't count on it vaporizing to carbon dioxide. If you take a diamond and you grind it down to a really fine powder, like powdered sugar size grains of diamond, that's where it will probably start to react, because that surface area, oxygen is not going to pull carbon off of a big diamond. Yeah?
Is it 2 kilojoules?
It is. Yep. Yep. So with Hess's law problems, you're going to be given a target equation. This is the equation that we want to know the delta H of, and then all this is just information that you can use. So determine delta H for this reaction. We need to come up with a setup in which graphite is in the reactants and diamond is in the products. Well, if I need graphite in the reactants, I'm in good shape because graphite is already in the reactant. So I don't have to do anything with the first equation. It's already got graphite on the left side. So I'm just going to bring that first reaction down. C graphite. No, plus water, or plus oxygen. Up. Yield CO2. Now, and the delta H, since I didn't do anything with the reaction, I'm not changing the delta H on. It's negative 394. I need diamond to be a product. Well, I see diamond. It's only showing up right here, but it says a reactant. So I'm going to need to take that second reaction and turn it around to make CO2 the reactant, and then these two things the products. And that's fine. If this reaction gives off 396 kilojoules, that means the reaction going in the other direction would take in 396 kilojoules. That's all that means. So I'm going to go ahead and turn that reaction around. So it's going to look like this. CO2 yields carbon as a diamond plus O2. And then since I turned it around, I'm going to take that delta H and change the sign on it. That would be positive 396. Add these two equations together. And we have some things that will cancel out, like we saw in the other example. The CO2s cancel out. The oxygens cancel out. And what we're left with is what we hoped for. Carbon is graphite. Yields carbon is diamond. And the delta H for this reaction, according to Hess's law, would be that plus that. Yep. Positive 2 kilojoules.
So it seems all easy, but I feel like it's going to get really hard.
I'm going, before we do another example together, I want to just show you the problems in the book, starting at 72. Okay, take a look at number 72. This is a Hess's law problem where you're given three chemical equations and their delta H's, and the question is, what is the delta H for this reaction? So you're going to use these equations. You may have to manipulate them. You will have to. I can tell you right off the bat, we need CLF to be a reactant in our target equation. So you're going to look for CLF up here, and I see CLF right there. And that's the only CLF I see in the three equations. Yes? Do you see any others? No. Now this equation has a 2 in front of the CLF. Well, my target equation doesn't have a 2 in front of it, it just has a 1 in front of it. So I'm going to have to take this equation and divide the whole thing through by 2, including the delta H.
Did you multiply the...
This one?
Yeah.
No, we are going to get to this equation. You can't mess with that one. So you have to fashion the rest of these so that when you add them together, you get this equation. That's what Hess's law does. And then ultimately, when you've manipulated them and had to change some of their delta H's, then you just add the delta H's up, and that'll be the delta H for your target reaction. That's what we're doing. Yes?
In order for graphite become CO2, what happens to the impurities in carbon graphite? Are there impurities in graphite?
Yeah, you're assuming it's pure, though. I mean, that equation doesn't take into account any impurities. Every chemical equation assumes purity. Yeah. Don't start doing that. Okay, so you can see that number 72 is pretty simple. You have three equations to manipulate. 73 is the same kind of thing, three equations. But then, oh yeah, look at this, 74 starts getting a little saucy there. There's 4 equations you have to manipulate. And then in 75, 5 equations. And then, yeah, you're going to try to come up with the delta H. And then 76, oh, 76, we're going only down to 4 equations. That's a nasty thing, though. I'm telling you, the Zoom dolls are getting old, but they still have their nasty. They are. They come up with some things and you think, oh my gosh. They come up with it. You know that.
Could we just use that value for each one?
Yeah, I mean, Hess's law is another way of finding delta H. So you have now 3 ways to find delta H. You have the heat of formation table, where you add all the products up, add all the reactants up, products minus reactants. That's the first way that we learned. Then the second way that we learned is through the reading quiz, where you look at the bond energies of the things that are breaking bonds, their positive values, and things that are forming bonds, their negative values, find the delta H that way. Hess's law gives a third way to find delta H. So there's 3 different ways you can find delta H. Depends on what the problem gives you. Your question is, couldn't we just look these up on the heat of formation table? Yep. But I might give you a problem in which I don't give you a heat of formation table. I say, okay, here's 4 equations, 5 equations, and then find the delta H from those. And you're stuck using Hess's law, so you have to know how to use it. Memorize the table, then you're fine. Yeah.
That's 4 pages.
Okay. Now here's another example. Let's try to do this one. This one at first looks scary because you have partial number coefficients, but it's not scary. It's good.
Halfway there.
I'm a little nervous that my iPad is going to die. When I started, it only had 10% charge. What is
Yeah,
it now?
Halfway there.
Oh! It's dying fast. Now I have tons of outlets in the room. I don't know though if I had to go to the back of the room if. Well then, he'd be recording from behind me.
Or you can use that phone if you want.
I'd rather use that just because it's got my account on it. And I had the reason I say this is because I had somebody record with their phone, and I gave them my username and password to upload it to YouTube, and it wouldn't work. In fact, I got an email later that night that said somebody tried to log on to your account. Who cares? It's a YouTube account. But anyway, I could see how that would be. It's not really a who cares because we don't want that kind of thing. With all the electronic bullying that goes on, you don't want to access other people's accounts.
I can go back and I zoom in.
All right, let's do that. So,
doesn't matter.
I think it's sexualized harassment.
I think it's more mentality. Yeah, I think that's more mentality.
I can smell it.
Yep.
They enjoy house harassment.
Did you figure this one out while you waited?
Wait, no.
Okay, let's do this one. Here's our target. This is what we want to find the delta H for, given the delta H of these two reactions. So if I want N2 and water in the reaction, now the way that I attack these problems, I just look at the reactants. I try to get the reactants to look the way they should and then hope that the products turn out correct. And usually that works. So if I want two N2s on the left, I look up here at my given equations and I only see one term that has N2 and that's right there. But it's in the products, I want it in the reactant side. So I'm going to have to take that first reaction and turn it around to get N2 on the reactant side. But it should have a 2 in front of it. This one only has a 1/2 in front of it. So not only do I need to turn it around, but also what I have to do to it. Multiply by 4, because 1/2 times 4 is what's going to give me the 2. So before we do that, I'm just going to make a plan here. I'm going to multiply this thing through by -4. The negative to turn it around, and then the 4 so that my coefficient's right. You with me? I also want 6 waters on the left, and when I look at my two given equations, I only see one water term, and it's right there. So again, I have the water on the product side. I need it on the reactant side, so I'm going to have to turn the second reaction around too. And then what else? Multiply by 3, right, to get that 2 to become a 6. I've got to turn this around, so it's going to be times negative, and then a 3. So I have 6 waters. Okay, let's go ahead and do that and rewrite our given equation. So for this first reaction, we've got a 1/2 N2s times 4, so it's going to be 2 N2s. And then I also need 3/2 times 4, 6 hydrogens. Yields, this thing times 4, 4 NH3s. This should still be balanced. And now I also have to do the same operation to my delta H. Since I multiplied through by -4, I've got to multiply that by -4. You do that without calculators? When you have to multiply by 4, double it twice. So 46 times 2 is what? 92, and then times 2 again.
184.
184. And change the sign.
Negative.
So the delta H is negative 184.
How'd you get
I was caring about the N2.
Oh,
Yep. So now let's attack the second one. We need to turn that thing around and then multiply by 3. So multiplying this by 3 is going to be 6 waters. And then multiplying by that by 3 is going to be 6 hydrogens. And then 3 oxygens. All right. Now we have to multiply this thing by 3 and we can't use a calculator.
1452.
Huh?
1452.
It is -3, yeah. So it's going to be a positive number because the negative is going to change it. Is this close enough to 500 just to call it 500? 500 times 3 is nice, 1500. But we were off, when we do that estimation, we're off by 16, aren't we? So if I just assume that that's 500 and multiply by 3, if I wanted what the actual answer was, make it 500 multiplied by 3, but then you have to correct it back. Subtract 16 times 3, which is 48. Yep. So it's 1452. Positive. If you didn't catch that, just call it 1500. It'll be close enough. Okay. So I have got my reactants to what I wanted. I wanted 2 N2s on the left. I got it. I wanted 6 waters on the left. I got that. Now I'm just going to hope that my products have worked out. And anything canceling out? Yeah, this thing and this thing cancel out.